So now we have data types, let's start to write some programs to do stuff with them. Most of the programming you've seen so far is programming by doing, where you give the computer a sequence of instructions to execute one by one together with some control flow. Ask isn't like that. Programming in Ask is programming by being, where we tell the computer what we want the result to be, but we aren't so specific about the exact sequence of steps to compute it. The technical terms for those are imperative programming for doing and declarative programming for being. So in Ask, we do declarative programming. Here's a data type that I didn't show you last time, the type of Booleans, which I will write as data bool equals true or false. So bool is a data type with two values, which have the names true and false. Now, let's say I want to write the function not, which has this specification. If I input true, then it should output false. And if I input false, then it should output true. The first thing I need to do is to write the type of not. Not is a function which inputs a bool and outputs a bool. So I write not, then the double colon sign, and then bool, arrows, bool. So you don't need to worry about this line too much yet. But one thing to be aware of is that the arrow symbol is used for both the implies connective in formulas when we're proving things, and also for building function types when we're programming things. On the next line, I'm going to write define not be, followed by a question mark. This is what the initial state of a question will usually look like. We'll give you the type, and then we'll write define thing and the question mark. And then your goal will be to complete the definition. So here, B is the name of my input. So what the function not needs to do is to look at its input and then to do different things depending on what the input is. So I'm going to write define not B from B. And I'm going to send this to ask. And ask responds by listing all of the different things that the input could be. So we have define not true and define not false. Both of these have question marks because ask doesn't know how those things should be defined. So this is a sort of interactive programming, just like we had interactive proving, where ask does everything that it's able to do without being able to read your mind, and you have to hold up your end of the bargain by supplying the rest. Now I can fill in the rest of the definition by replacing the two question marks. I say define not true equals false and define not false equals true. So the equal sign is used for specifying what the output of the function should be. Now, when I send this, ask changes all of our defines into defines, which is its way of telling us that this is a complete definition. Okay, this is a really simple function, but it already shows us a general pattern for programming in ask. First, we deconstruct the input using from, and then we construct the output using constructors of data types. So in this case, true and false are the names of the constructors of the bool data type. Okay, as a historical note, the idea of programming by deconstructing the input and splitting into cases is called pattern matching, and it was actually invented by Connor's father, Fred McBride, and now it's part of basically every modern functional programming language. Okay, let's do some more examples. I'm going to rewrite the definition of natural numbers that you saw in the last video. So data nat equals 0 or the successor of a natural number called n. Okay, let's write a function that detects whether a natural number is positive. So 0 is not a positive number. So if you input 0, it should output false. And if you input any natural number other than 0, then it should output true. So I'm going to write positive is a function from nat to bool, because this is a function that inputs a natural number and outputs a Boolean, true or false. And I'm going to write define positive x with a question mark. Okay, so we need to look at what the input is. So I'm going to replace the question mark with from x. Ask replies telling us that the input could either be 0 or it could be a successor. And in the second case, it's actually given a name to the parameter of the successor constructor. So when the second case runs, we know that x is the successor of n, or in other words, that n is x minus 1. And notice that the name that ask generated for us here is the same as the name that we wrote here for this parameter when we defined nat. Okay, so we can start filling in this definition. If the input is 0, then we know that the positive function should return false because 0 is not positive. And for the second case, if you think about it, if the input is the successor of anything, then it can't be 0. So it's positive no matter what. So we can ignore n and we can write that the function should return true. Now we send this and all our defines have changed into defines. Okay, let's do one more example. Here is the data type of pairs. I write data pair A, B equals make pair for the name of the constructor, and then a first thing, which I will call first of type A, and a second thing, which I will call second of type B. Let's write the function swap that reverses the order of a pair. So if you have a pair of an A and a B, then the output of swap is a pair of a B and an A. So the type of the swap is it's a function from pair A, B to pair B, A. So just like we could have parameterized data types with some parameters, we also here have a parameterized function. You don't need to worry about that too much yet if that doesn't make sense. So let's write define swap x question mark. Okay. And I'm going to replace the question mark immediately with from x because we need to look at what the input is. And ask tells us that the input is a pair consisting of a first thing and a second thing. So now what we can do is to make the output, we reconstruct the pair, but this time in the opposite order. So I can write equals make pair second first. And then we're done. Okay, one thing you've probably noticed is that all of the functions we've defined in this video are really simple, even if the style that we're programming them in doesn't look so simple. The reason for that is that we don't have any kind of looping construct yet. So that's the topic of the next video.